and this is my first video on my channel, the medical stores. So today we are going to read about amino acids. We are going to know some basic properties of amino acid, their types, their structures. So let's get started. We divide these amino acids into two groups. Okay, so one group is polar amino acids, another one are non-polar. So what is the difference between this polar and non-polar amino acids? So polar amino acid means these amino acids are hydrophilic in nature. These are hydrophilic, and the non-polar amino acids, yes, it is hydrophobic. So basically everyone knows the difference between the hydrophilic amino acids and hydrophobic. Hydrophilic amino acids are amino acid which has love towards water, and hydrophobic which hates water completely. Okay, so further this polar and non-polar. So basically we are having total 9 polar amino acids. It is 6 polar amino acids and 9 non-polar amino acids. So I have made some mnemonics, but it is not related to something that we may memorize it or something we can remember, but it are just the alphabets which we can remember. So the mnemonics for polar amino acids is ST, CT, AG. It is quite understandable. ST, CT, AG. I don't know if it is good enough, but I think for me it has been helpful. So for non-polar amino acids, the mnemonic is GAO. You can tell, like GAO. LIMP, 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 and TP. So we are going to see what are the amino acid related to this. So for non-polar, first comes S, that is serine. Next is T, that is threonine. Third one is C, which is cysteine. Cysteine is the amino acid which has sulfur group. So we will say it further in the structure of amino acids. Next one is T, which stands for tyrosine. Next one is A, asparagine. Next one, the last one is glutamine. So these are the polar amino acids. Next one we will see non-polar. So the non-polar amino acid is, first one is glycine. Second one is alanine. Third one, valine. Fourth one is leucine. The fifth one is isoleucine. Next one is methionine. Methionine is also one of the amino acid which has sulfur group. So the important is methionine, which is a sulfur group donor. So remember it. And the next one is phenylaline. We will see in further videos the disease related to phenyl, which is due to deficiency of the enzyme phenylalanine dehydrogenase, and which gives us the disease phenylketonuria. We will see it in our future videos. So the next one is tryptophan, and last one is Prolene. So basically this is the differentiation of the amino acids into polar and non-polar. So I don't know this mnemonics will be helpful to you or not, but it has been helpful for me. So the polar, for polar it is STCTAG, you can remember it, and for non-polar it is cow limp TP. So I have remembered it in this way. So next, we have seen polar and non-polar amino acid, which are the non-polar are 9, polar are 6. So further, there is more differentiation of amino acid into acidic amino acid and basic amino acid. So what do you mean by the acidic and basic amino acids? So basically acidic, as we know, acidic means these are proton group, proton donor. Yes, it gives out the proton, that is proton, basically it is H. So these are proton donor and they become negatively charged. So the acidic amino acids are negatively charged, whereas the basic, yes, opposite of this, these are the proton acceptor. These are the proton acceptor. It accepts the proton groups and it itself becomes positively charged. So the basic amino acids are positively charged. So the differentiation is acidic amino acids, there are only two. One is aspartate, the next one is glutamate. And the basic amino acids are three, which is lysine, arginine, histidine. Topic is the structure of amino acids. So here are the structure of the non-polar amino acids. So as we know, that our mnemonic for this non-polar amino acid is GAU, LIMP, TP. So the first amino acid is glycine. You can see that I have marked the red line for few carbon atoms. So it indicates that these are the extra group which are added after the previous amino acids. You will understand it. So the first one is glycine. It has carbon central atom, carboxyl group, amino, and it has 2 hydrogen atom. The next one is alanine. The alanine structure has the same carboxyl group, the amino group, the hydrogen group, but the hydrogen group of the glycine, it replaces methyl group CH3. So it becomes alanine. Further, for valine, we have same structure, but valine is a branching amino acid, branch chain amino acids. So it has CH, and it has 2 chains of methyl group. So this is valine. Next one is leucine. So leucine is also one of the branch chain amino acids. So it has carbon atom at the center, the hydrogen, the carboxyl group, the amino group. So the added one is CH2 group. Only one extra group is added from, you can see in valine it is CH. Here it is CH2, which is added somewhere here, and the further chain is the same. So it is quite easy if you follow from start to end the amino acids. So leucine. The next one is isoleucine. Isoleucine. Isoleucine is also the branch chain amino acids. So we have total 3 branch chain amino acids. 3 branch chain amino acid we saw now is the valine, leucine, isoleucine. Okay. So the next amino acid is methionine. I have told you that methionine is the sulfur group donor. So I have marked here sulfur. So it is the sulfur group donor. It has the normal structure: central carbon, carboxyl group, amino, the hydrogen atom, and it has one methyl group and these 2 carbon groups, and in the middle sulfur group. So basically you can make it out that it has 1 sulfur group, so it is methionine. We have seen the 6 amino acids, the nonpolar, and the more 3 of them are phenylene, which has an aromatic ring in it, tryptophan, you can see these aromatic rings, and Prolene. One thing I have to tell you about Prolene is it has a secondary amino group. It means that you can see this is the amino group, and this amino group is attached to 2 carbons. One is this one and the other one is this. So it is the secondary amino group, and the rest of all the amino acids are primary. So you can see it, primary amino. See, amino group attached to the 1 carbon. Here also it is attached to the 1 carbon. The all amino groups in all amino acids are attached to a single carbon. So they are the primary amino groups. So they are primary amino groups. And the only exception for this is Prolene, which has the secondary amino group, as it's the amino group of Prolene is attached to 2 carbons. So it has a secondary carbon amino group, so it is the exception for that. Okay, the next we are going to see the polar amino acids, structure of the polar amino acids. So one more thing I forgot to tell you, that Prolene is not the aromatic ring. It does not contain the aromatic ring. I have just shown it here because I have to show you the exceptions. The aromatic rings have the amino acid which has the aromatic rings are these 2, phenylene and tryptophan. So sorry for the confusion, but Prolene is it does not have the aromatic ring. Okay, so polar amino acid, we have discussed there are 6 polar amino acids: serine, threonine, tyrosine, asparagine, glutamine, cysteine. So here we have talked about cysteine. It has sulfur group in it. You can see the structure, it is completely different from methionine, but the cysteine has sulfur group, but it has the important function of it. So the sulfur group donor is methionine. So here also I have marked in red some few atoms. So first one is serine. So it has the simple basic structure of the amino acid: carbon group, the carboxyl group, the amino group, and here the second carbon has 2 hydrogen group and 1 hydroxyl group. So see, it has 1 hydroxyl group. Next we are going to say is threonine. It has the same structure, but only the difference is that the hydrogen group is replaced by the methyl group, and this gives us the threonine. Okay, so it is understandable. The next one is tyrosine. Tyrosine is one of the amino acid which has the aromatic rings. Last we have seen in nonpolar there are 2 aromatic rings amino acid, which one was phenylene and the other one was tryptophan. The third one is tyrosine. So the structure is quite easy: carbon atom, hydrogen, carboxyl group, amino group, methyl group, and the aromatic ring which has the hydroxyl group. So it is easy. The next one is asparagine. Asparagine, you can see some common in this asparagine and glutamine. Yes, the carboxyl group, the free carboxyl group. Okay, so the structure are quite similar. The small difference is that the asparagine has one CH2, 1 carbon which attached to the amino and the carboxyl, and 1 extra carbon is added in glutamine structure, which gives us the glutamine. So it is quite understandable, easy to learn. And the cysteine is last one is cysteine, which has basic structure of the amino amino acids, and one carbon, extra carbon is added, and the sulfur group. So cysteine, methionine are the sulfur group. There are amino acids which contain sulfur group. If they asked you which are the amino acids which contains the sulfur group, so it is cysteine and methionine. But if they asked you which are the important donor of the sulfur group, so it is methionine. Okay. Next we are going to see some few characteristics of amino acid. I can say it exception of some amino acids. I think we have already discussed in the last section, but we will do a quick revision. So I have told you that all amino acids, all the 20 amino acid has a primary amino group. All the 20 amino acid, all amino acids, I will write in short AA, all amino acid has primary amino group. The only exception I have told you for this was Prolene. So the exception for this was Prolene, which has secondary amino acid. Okay. And one more thing, there is exception is all amino acids are chiral. Do you know the difference between chiral and achiral? So basically chiral means the structure of amino acid, okay, the normal structure of amino acid, and its mirror image, okay, and its mirror image are not superimposable. Okay. Chiral means the normal structure of amino acid and its mirror image are not superimposable. So all amino acids are chiral, means that the normal structure of amino acid and its mirror image are not superimposable. The only exception for this is glycine. Yes, glycine. So we have to look at the structure of the glycine. It has the central carbon, carboxyl group, the amino group, and it has 2 hydrogen. It does not carry a methyl group. So you can see this, the mirror image of this would be impossible. So the glycine is achiral. Okay. So next one is, we have seen 3 amino acids which are called as branched chain amino acid. Branched chain amino acid. We have seen this during the structure of amino acids. So we will do again. There are 3 branched amino acid. The first one it is valine, isoleucine, leucine. So I think it is easy to remember. No needs of some mnemonics. So these are branched amino acid. And one more thing I have to tell you about branched amino acid is metabolism takes place in muscles. Now we will see it in our future videos in more deep. So these are branched amino acids, and we have also seen the amino acid which has aromatic side chains. So these are also three. We have seen these are also three. So these are phenyline, tryptophan, tyrosine. So from this we have seen phenyline and tryptophan are non-polar. Okay, these are non-polar amino acid and tyrosine is the polar amino acid. You should remember this, which are polar, which are non-polar. Okay, so next I want to tell you about asparagine and glutamine. We have seen the structure of asparagine and glutamine. So here it is, asparagine and glutamine. I have told you the common thing in this both, it has the free carboxyl group. So the amino acid which has the free carboxyl group is free to bond with the hydrogen. So asparagine and glutamine, these two amino acid basically perform in hydrogen bonding. Okay, the free carboxyl group bond with the hydrogen. So today we completed some topics about amino acids. So we started from the basic structure of amino acid, and we divided amino acid into two groups, the polar, the non-polar. I have suggested some mnemonics. I think it may be helpful for you. If not, there are many more mnemonics you can search on Google. So polar amino acids, non-polar, with the mnemonics, the exception of the two amino acid which has the sulfur group in it, which is cysteine and methionine. So after this we saw differentiation of acidic and basic amino acid, where we saw in acidic there are two amino acid, aspartate, glutamate. In basic, this lysine, arginine and histidine. So after this we saw the structure of amino acid. We saw the structure of amino acid, saw glycine, alanine, valine. Next we saw leucine, isoleucine, methionine, which has a sulfur group in it. It works as a sulfur group donor. And more, we saw phenyline, tryptophan, Prolene. So your phenyline and tryptophan are the aromatic. It contains aromatic side chains. These are aromatic ring amino acid which has aromatic side chains, but Prolene it does not have the it does not have the aromatic ring, but it gives a structure of ring, a five member ring structure, but it does not has the aromatic ring. And the exception which we have discussed for Prolene is it is the only amino acid which has secondary amino group in it. Rest all amino acid has primary amino group in it. Okay, so if you want, you can to see it, you can just pause the video and just take a screenshot. Okay, next we saw polar amino acid. We saw 6 of them: serine, threonine, tyrosine. Tyrosine is the amino acid which has aromatic side chain. Next we saw asparagine, glutamine and cysteine. Cysteine amino acid, it has cysteine it has the sulfur group in it. So next we saw for asparagine and glutamine, we have seen the common structure in this, that is the free carboxyl group. So I have told you this free carboxyl group, it is free to make a bond with hydrogen. So the asparagine and glutamine are free to make hydrogen bond with any of the atom. Okay, so after this we saw a few characteristics of amino acid. So we saw that all I have told you this, all amino acids have primary amino group. Only exception here was proline. Next we saw that all amino acids are chiral. Exception for this is glycine. Further we saw branch chain amino acids, which are 3: valine, isoleucine and leucine. The next one we saw aromatic side chain, which are 3: phenylene, tryptophan and tyrosine. Out of this, phenylene and tryptophan are non-polar amino acid, whereas tyrosine are polar amino acid. So this is the end of my video. I hope it was helpful to you. So during the introduction of my channel, I have told you that I will suggest some books for this. So I basically refer Lippincott for biochemistry. So yes, so this is the book which I refer, Lippincott. The writer for this is Richard A. Harvey. I think this book is quite easy to understandable. The language is easy, and further, so these are the topics in these books. So these topics we are going to cover in our future videos. And today we saw amino acids. I would like to show you something that yes, this it has a quite good structure of all the amino acid in it. You can see this glycine, alanine, all. It is quite good to it is good to do a quick revision of the amino acid, its structures. So I like this very much in this book. And one more thing I have to show you is it has this, yes, the unique letters for each amino acid. You may have these questions in your exams. So this table is quite easy to learn, and it has everything, each and every amino acid in it. So we can just go through it twice, thrice, and we will get all the letters related to each amino acid. So yes, I will suggest you this book, Lippincott. I find it more easy and more easy to understand. The language is easy in it, and the diagrams, the explanation, it is quite easy. So I will suggest you this book. So if you want, you can just download it from Google. So we complete our video here. So thank you for watching, and if you like the video, please hit the like button and do subscribe my channel. Thank you.